Okay, Sai, let us proceed now. Yeah.
So good evening to all the participants. Once again, on behalf of IT Pune chapter, Buds Engineering Academy and Civic Incubation Center, I welcome all the participants to our day 19 session on AI/ML for Internet of Things, our 1 month workshop. So moving on and diving into our topic, we have an eminent speaker today with us, Dr. K. Padmavati, ma'am, who is currently working as Associate Professor, EC Department at Stanley College of Engineering and Technology, Abbots, Hyderabad. So, ma'am, on behalf of IT Pune chapter and Buds Engineering Academy, I welcome you and I would request you to please take over the session and dive us into the concepts of AI/ML and IoT. Over to you, ma'am.
Yeah.
Thank you, ma'am. Okay.
Yeah. Can you hear, ma'am?
Yes, I can hear you.
Yeah,
And
yeah, yeah. Go ahead.
am,
Go ahead.
am I audible to you all?
Yes, yes, you are audible. Yeah, yeah.
Okay. We need to use the entire screen, I think, right?
To
Window
share
is,
entire screen. Yeah,
yes, entire screen.
yeah.
Is it visible to you,
Yeah,
sir?
yeah, visible. Yeah, yeah, visible. Yeah, yeah.
Okay, I'll try opening this. Is it in slideshow? That
Yes, ma'am, it is in slideshow mode.
Yeah,
oh,
visible. Yeah.
okay. So I may not be able to see the chats I think when I'm like this. So at the end of the session, any doubts, all of you can ask me. As of now, since I have put it in slideshow, um, I may not be seeing the comments. Okay.
Yeah.
I'll do one thing. So, uh, hello all of you. So I'm Dr. K. Padmavati, and today I would like to talk about sensors and actuators in the field of, in the context of AI/ML and IoT. So as part of this session, I would like to start my presentation on these points. I would like to discuss about the introduction of AI, types of applications, then introduction to IoT, what is the IoT ecosystem, and what is a smart environment, how IoT has integrated into our lives, and what are the advantages, disadvantages. With this requisite means if we just an introduction to these concepts I'm going to give, but our main agenda for today is sensors and actuators. Therefore, with this briefing, I'm going to start the introduction to sensors and actuators. What is the difference and what is a smart sensor and what is the architecture, fabrication, advantages, disadvantages, and the applications of these sensors and actuators in our IoT and AI. And finally, I will summarize. So hope I'm audible to you all.
Yes, audible, ma'am. Audible. Yeah.
Okay, so
Participant should speak or will unmute also. You can have a queries in chat box. Yeah. Go
okay.
ahead, ma'am.
So first of all, artificial intelligence. I'm starting with artificial intelligence. Why? Because main thing means whether we are talking about IoT sensors or we are talking about networks, neural networks, anything, what we are trying to do is to build a machine which can act like an human brain. Means the artificial intelligence, whole of the concept or whole of the technology is revolving around devising a machine or designing a machine can act on its own and work as an human brain. And to make it work as a human brain, what are the things which are to be embedded into that system is nothing but our artificial intelligence technology, which you already might have discussed in your today's 19th day of class. Therefore, you might have known what do we define by AI, ML, what is the relation, and what is IoT. But still, I'll give you the definition of artificial intelligence and few things related, which will be helpful for me to continue with the sensors and actuators. So, designing a human brain which can work as designing a human brain with machines and components is nothing but an artificial intelligence, and which requires lot of sensors, lot of neural networks, lot of deep learning. Many technologies are involved in order to come up with artificial intelligence. According to the father of AI, John McCarthy, artificial intelligence is a field which combines computer science and robust data sets to enable problem solving. It also encompasses subfields of machine learning and deep learning, which are frequently mentioned in conjunction with artificial intelligence. These disciplines are comprised of AI algorithms, which seek to create expert systems which make predictions or classifications based on input data. So this was the definition given by the father of AI, who is called as the father of AI, the John McCarthy. And he says, you can see from the words which are used, it is a combination of computer science and data set. So when we talk about data sets, it's nothing but like data. We are going to work with big amounts of data to make it work and combine the effects of computer science using the algorithms, machine learning or deep learning algorithms, and we are going to have predictions based on those data, and it is going to act on that data, predict on that data, predict based on that data and make a decision. So that is what an artificial intelligence is. And it can also be called as the process of building intelligent machines from vast, one second. One second, sir.
Yeah. Oh, okay, ma'am.
Since my data is not good, I
Yeah.
have with my video. Okay.
Okay.
Yeah. So artificial intelligence is the process of building intelligent machines from vast volumes of data. And these data helps in making the machine to learn from its past and perform a task like human. Okay. And it is going to enhance the speed, precision, effectiveness of human efforts. And to get these, AI is going to use complex algorithms and methods to build machines that can make decisions on their own. So machine learning and deep learning are the core algorithms which we use in artificial intelligence. So with this preface, just we'll go through what are the types of AI we have. Artificial intelligence can be divided into two based on capabilities and based on functionalities. So there are three types based on capabilities, which are narrow AI, general AI, super AI. So and this narrow AI is also called as weak AI. You might have already discussed about these things in your previous classes. Just I'm going to revise you here. So narrow AI is also called as weak AI, and then general AI, super AI. Next, based on the functionalities, what are the functions they are going to perform? How are the functions they are going to perform? There are four types of artificial intelligence, that is reactive machines, limited theory AI, theory of mind AI, and self-awareness AI. Okay, so these are basically the first and second type of AI. And what is narrow AI? So you can see the classification. Artificial intelligence based on capabilities, narrow, general, and super AI. Based on functionalities, it is reactive, limited memory, theory of mind, and self-awareness. Now let us see what is narrow AI. So narrow AI is a one which can do only one specific function. Means it is limited. Its functionality is limited to one specific function, and it means it targets a single subset. Means if at all it is focusing on vision related concepts, means it is like face detection, for example. So it can only work with face detection operations only. So it is limited to face. So if there is instead of face some other image is being placed, then it will not work. It will not be able to identify that particular object. Only face it can identify. So such technology which can work only on one narrow task is called as narrow AI. Okay, hope I'm clear. Next, general AI. General AI is also known as strong AI, which can learn, which can understand and learn any intellectual task that a human can do. Okay, so here it allows a machine to apply knowledge and skills in different contexts. What do we mean by this is, where in weak AI, only one task was assigned. Whereas here, in general AI, we are going to have multiple tasks. Multiple tasks can be done. And whereas super AI surpasses the human intelligence and can perform any task better than an human, where like they can be more fast, and these can be helpful. For example, in robotic arm, in industries like automation, packaging, and all, if you see, what is happening is the robotic arm is going to do repetitive work at a faster space. Just telling it as an analogy. It's not the example, just an analogy I'm using. Super AI is the one which can work more vividly than a human intelligence. It can take decision very quickly, and it can also evoke emotions, needs, beliefs, like as you see in movie that is Robo 2 Robo is there, no? So like some emotions, some needs, some beliefs, like that, if at all they are all added to an machine, then it becomes a super AI. And now many times most of the engineering students are doing their many projects or major projects like that, where they are identifying the emotions, means based on an image of a person. They are identifying whether that person is happy or sad, or they are sleeping, or they are inactive, like that. So emotions are being um, detected using this super AI. So all this put together will become an super AI. And coming to the next classification, where we called as functionalities, based on functionalities, the AI is a reactive machine, limited memory, theory of mind, and self-awareness. And you can see here, the reactive machine is a primary form of AI that does not store memories or use past experiences to determine the future actions. So here it's like you might have learned about Mealy and Murray machines in your um, digital electronics, or I can call it as switching theory and logic design, sequential machines, right? In sequential machines, you have Mealy and Murray machines, where one machine has got memory and the other doesn't have a memory concept. So here, a reactive machine is a machine which doesn't have any memories, and it simply takes the decision based on the present data. At this moment, whatever data you give, based on that data, it is going to react. So they don't take past experiences into consideration. Okay, so they they are provided with specific tasks, and they don't have capabilities beyond these tasks. Where next technique is limited memory AI. So this trains from past data to make decisions. So what do we understand by past data to make decisions? What happens in this limited memory AI is, whatever for example, you can have a uh, do a small project where fraud transaction detection can be done in limited memory. So an example is fraud detection using some forest random forest algorithm. Means one of my student has done an mini project where what they have done is they have from one point of time, let us take from the past April or from January, they have taken all the, means they have saved all the data of the transactions, and from that data what they have done is um, they have they have collected some attributes to find out whether that type of uh, transaction is a true transaction or a fraudulent one. Okay, so in that case, what happens is, when we do a new transaction, that new transaction will be from the new transaction, whatever the attributes or features are required to check whether this particular transaction is a fraudulent or not, it is going to acquire those features. And these features are checked with the past data features, which are the test data. And based on these two comparison, it is going to predict, or it is going to make a decision. In case it feels that it is an fraudulent data, it will roll back that transaction. So what happens by this is, it is taking a decision whether to pass on the transaction or to cancel the transaction based on the past data. Okay, so that is limited memory one. Next one is the theory of mind, and it this exists only as a concept. and still people are working on this, where this type of AI requires thorough understanding of the people and things within an environment, and it can alter feelings and behaviors. It's like a super thing which can work um, with advanced class of technology. So next, the last one is the self-awareness AI, which exists only hypothetically. So now we are in a phase where we have a reactive machine and a limited reactive machine AI and limited memory AI. And we are working on theory of mind AI, but self-awareness AI, still we haven't started yet. And definitely after some, in the future, you can have self-awareness AIs. Okay. So you can see there are numerous applications of AI. So in speech recognition, for customer service, for computer vision, recommendation in your nowadays all of you are using Amazon, Flipkart, and many e-commerce e-com sites, right, for buying online. So the moment you search for one thing, you will be getting recommendations for similar items, and there are many ways in which you can search for an item, by using a picture, by using a keyword, by using some, and even like when you want to find out which song you have, means you wanted to find out the song is from which particular movie. If you hum the song into your Google Assistant, it is going to means if you properly hum the song in with using proper lyrics, it can tell you which movie song it is. It can display that song, and these all are like recommendation engines. And you can have an stock trading. And nowadays each and every student, even if a student like who is having a knowledge of trading stock markets and all, are going through the stock markets, and AI is going to help in that. And with this, I'll just wind up the uh, AI. And here we have mentioned why I have started with AI is, we have artificial intelligence is like a big umbrella, and under that umbrella many of these things like IoT sensors, many of them are integrated. The integration of all this will give rise to AI. So I have started with AI first, and for AI we need to have, means artificial intelligence is going to um, embed, or we can say it is going to mix computers algorithms with the data, right? So to get the data, we are going to have the data, we need some devices. And how are we going to get the data from the devices? So getting the data from devices for automation purpose and all requires this IoT technology. And what is this IoT? Is nothing but Internet of Things. And you can see this is the Earth, and the various hexagonal shapes represents an IoT device, and this IoT device is connected with internet, and all the IoTs, all the smart devices on the earth are connected into an internet into a network which are connected by net, and this is nothing but the Internet of Things. So what is IoT? So it is simply an integration of several technologies and communications and solutions, or you can say the devices connected to internet communications with other devices which share, analyze the data to solve problems and improve the efficiency. So this is what you can see from the pic, where from different households, each of our house has got, is like a mine of smart sensors. Your mobile phone, your laptops, your washing machines, which are smart washing machines, I'm saying. So all the uh, devices which have got the facility to be connected to internet, those are all connected by net, and those all becomes our source of input, or those are the one from where we get the data. And these data is collected and stored in cloud, and that information will become our past data or data for prediction. So IoT is the one which connects all these sources of data. So if you see, the internet is there uh, right from devices, on person, any service, any network, any place, or any control. Means it has reached, it has moved into all these things. The IoT has moved into all these things. And according to an internet cartographer, means there is one concept called as internet cartography. You can just Google it and check, where this person has found out, means created a group, created a map showing how far the IoT technology has been spread. So here if you see, and they have used some pseudo color processing, where highly means where whichever areas have got high number of IoT devices or smart devices, those are represented by a red. Red shows lot of web-enabled devices, while green areas contain fewer. Black areas are the regions where no signals were received. So this is at one point of time. Okay, so this was at one point of time, and this was an image which was taken in 2017. I couldn't find the recent one, but just to give you an idea, like it was uh, a uh, internet cartography map which is given by uh, some internet provider in 2017. So if you can check, definitely now it will be very much higher. The black regions, you may not be finding the black regions much now. So let us see if I could, if you can see, if you can get it on Google. Okay. So now this IoT works in a smart environment. Means whenever we talk about the IoT, we are going to talk about the smart environment. What do we understand by smart environment? It is an environment where all the physical objects are connected by some connected by some network. Okay, so it is said as the physical world that is richly and invisibly interwoven with sensors, actuators, displays, computational elements, which are embedded seamlessly in the everyday objects of our lives and connected through a continuous network. So nowadays there are smart refrigerators, smart ovens, smart watches. Smartwatch comes under your wearable device, right? And there are Bluetooth earrings, Bluetooth wearables also, like Bluetooth ring, which they use for some specific purposes. Even washing machines can be operated by your mobile phones, your ACs, and whenever there is an API from which API is application development program. No, application peripheral interface or something. We'll just check it. So API is there. We are going to have, we can connect all our devices which are at home, and these are all smartly connected. So using your mobile phone, using your computer, laptop, even your smartphone, you can operate all these devices. Even your car has got a remote key. Before you go in also, you can switch on the AC, so that by the time you reach home, your AC will be at required temperature. So this is nothing but called as a smart environment, where all the devices are connected and connected by a network. So how IoT is integrated? We have it means IoT is used for identification and tracking technologies. We have wired and wireless for environmental conditions like temperature. In all the students, most of the students who do their projects in agriculture related projects, most of the times in agriculture related projects, what they are do is they are going to find out, means let us take smart irrigation control. Means irrigation means water control. Means we are going to have some humidity sensors, where whenever the humidity of the soil reaches below or the least level, automatically the drip system will work and water will be sprinkled. So that can be a wired one or a wireless one, or it can alert whenever the humidity sensor experiences a humidity less than the some threshold level. A message will come to the mobile, whoever has connected to that particular smart humidity sensor system, where by looking at the humidity, we can switch on the motor like that. So wired and wireless sensors and actuator networks, it has come. And next, in communication protocols, all the internet works on this communication protocols. And we can have a distributed intelligence for smart objects like wearable devices. Here you can see what are the wearable devices. Watches, rings, and all I have said you. And IoT is spread into many areas like building and construction, energy, consumer and home applications, health and life sciences, industrial applications, transport and logistics, retailing applications, security and public safety, and also into ICT. So this is just a image which I have taken from some site. Okay, so here you can see many applications are there. It's like everything you touch, every smart device you touch is a part of IoT. Okay, so how it is like building and construction? There are means new technology in building and construction is such a way that I have seen one one research topic I happened to hear, where now there are many buildings, very buildings of heritageal effect, like some monuments are there. So to find out whether the monument will be like that only without any damage, there is one method where they are going to insert one sensor like thing into that building at some special areas, like near the pillars, or where the weight is going to be there. Means, for example, for a house, a pillar is the one which is going to uh, bear the strength. So at such crucial points, a sensor is being placed, and that sensor is going to check the strength of that particular wall or the area, and it is going to estimate and give us whether there is any possibility of that particular construction to be damaged. So, and this sensor, again, it is a sensor which is connected to uh, a mobile or some computer device. So energy, you can know solar systems, or you can talk about generation, storage, transmission, distribution of electricity, and you have smart meters, oil platforms, refineries, wind turbines, hydro equipment, and nuclear power plants also we can see them. And coming to consumer and home, we have smart lights, okay, and we have smart cameras, video cameras, and security alarms, dishwashers, and all these, okay. And coming to health, the whatever the operations nowadays, some surgeries are performed by um, AI or robotic arms, and that is nothing but because of this IoT. Means online there will be a doctor who is visualizing what is happening, and based on the instructions given by the doctor, that robotic arm is going to move, and that is how some surgeries are being carried out, okay. So in health and life science, it is used like that. And x-rays, MRIs, robotics, ventilators, these are all the things. And industrial applications, there are vast applications, like in an industry where how much is the production, to what point the production has reached. So those all information can be there. And transport and logistics, now you can see where your parcel is transporting. Means whenever you book one parcel or an item, you are going to have an online information. You can check through the tracking ID where that item is. So that is how IoT is helping. And in retailing, like hospitality, stores, and then in security purpose, we are going to use it for surveillance. Being at far off place, if your CCTV is connected to your mobile, you can see from anywhere whether any person is there. By if your cam is on, you can check what is happening, and it can be used in ICT for cloud connectivity and all. Okay, so this is how the IoT is being everywhere around us. It has spread into our lives, and these are all different wearable devices. You can just see. And this Internet of Things value chain, how it works actually. Whatever the smart work module we are going to have, like smart modules can be SIM card, sensors, chips, and the information is passed to the smart object, and there should be some connectivity, and from there it will be connected to the platform where that information is being sent to software customization, and based on that the application is being done and it reaches the customer. So you can see just which are the companies which are dealing with the smart modules, smart objects, who are the one which are working with connectivity platforms, software customization, applications like that. And finally, these all people are going to help us for making our work to solve some problem, and who for whom they are solving is to a customer, and we come under a user or customers. So what are the benefits of IoT? You can divide the benefits or the advantages in two aspects, where IoT is used for domestic applications, and for working applications also. So in domestic, it can be used in domatics, which is home automation. You can have an assisted living, like using some robot or some health monitoring or home monitoring. A small thing like smart cradle. A smart cradle, few of the students are doing projects on smart cradle system, where if the child cries, automatically the cradle will be swinging in swinging mode. And there is a concept, means I have read one paper in which music is being added to that cradle whenever the baby cries. Some whichever the songs which we have selected, so those songs will be recited so that the baby sleeps. So it's like things are moving on. Maybe it not be like very good as in the movie of 24/7, or some movie is there, no, some Surya movie. But still, there are many things which are possible by this IoT. So it can be for monitoring of elderly people also, for e-health, and in the working, it can be used for industrial manufacturing, logistic, and all. So which makes our lives better. Okay, because with this IoT, being far away from the location also, we can do many things and find out many things. So that is how IoT helps us. And there is small drawback. There can, means wherever some advantages are there, some disadvantages also will be there. So there should be, means drawbacks means there should be higher degree of smartness by enabling their adaptation and autonomous behavior, while guaranteeing trust, privacy, information security. These are the three key points where IoT has to focus. And still, means there is much work going on to build the trust, privacy, and information security. And at times, we may feel that some RFID or something is being embedded into your skin. So it's like data valence, like surveillance. All means your data is being taken. So keeping track and watching over us, we may feel a bit problematic. So data valence, there can be implantable transponder chips. Like here an example is shown where it is an microchip implant in a cat, and here it is an RFID chip, which is just a bigger than a grain. This is the grain of rice, which can be used in inventory management, tracking goods. Okay, so if this is lost, we can't get the information about that. So with this basic idea, we'll move into the sensors and actuators. So till now we have seen what is AI and IoT, and your IoT is going to gather information from sensors and actuators, and based on this information and adding some algorithms, your AI is going to make decisions. So now let us see what is actually a sensor and an actuator. So basically sensors are the devices. So we can call them as electronic devices. So sensors are electronic devices that respond to a physical stimulus like heat, light, sound, pressure, magnetism, motion, etc., and convert it into an electrical signal. Okay, so sensor, what it will do? It will receive input. We can say that sensor is an input device. Sensor receives input from the external environment, or it will receive a physical stimulus, and this is a signal which is other than electrical. So heat, light, sound, pressure, magnetism, these are not electrical signals but physical signals, and these signals are converted into an electrical signal. So this sensor is said to be an input device, whereas actuator works as an output device. So what is an actuator? So actuator is the one which is going to convert this electrical signal which is received from the sensor into a physical stimulus or physical response, not stimulus, physical response. So these actuators are said to be output devices. And this input plus output, the sensor plus actuator, this both put together is called as a transducer. These both, sensor plus actuator, is called as a transducer. And this transducer, if the students who are in this workshop or seminar are of third year students or so, you may have already learned about electronic measurements and instrumentation. So that subject, in that subject, you have learned about different types of transducers. So transducer is a combination of sensor plus actuator. Just the difference between, what are the differences between a sensor and actuator? You can see that the sensor is an input device and your actuator is an output device. So sensor converts physical quantities and characteristics into electrical signals. Actuator converts electrical into physical action such as force and motion. And sensor takes inputs from the environment and senses surrounding conditions, whereas actuator takes input from output signal conditioning unit of the system. Sensors gives output to input, and here sensors are often used to measure process pressure, temperature, fluid levels, flow, vibration, speed, etc. Actuators are used to control valves, dampers, guide vanes to move objects from one place to another or something like that. So here some small analogy which I want to say is, let us take, there is a vessel on a stove. So let us take, you don't know whether that vessel is hot or cold, but you have just touched the vessel. Let us take the vessel is hot. So what happens the moment you touch, your fingers will feel the heat, and automatically the finger, your skin senses that heat and sends a signal to your brain, and the brain in turn will make your hand to be removed. You are going to, it's like an action which has got immediate response. Means once your skin feels the heat, automatically your hand will be removed from the pot or the vessel. So what is happening, even though it is very very minute or micro or nanoseconds, this action will have, this action and response will happen within nanoseconds. what is happening is your sensory organ, which is a skin, is going to inform your brain that you have touched a heated object. So your skin acts as the sensor and your brain receives that signal, and brain, what it will tell automatically, to move away your hand from that particular position, means from that place. So your brain is sending a signal to move your hand. So the movement of your hand is nothing but the output action. So it acts as an actuator converts electrical signal into physical action. So here you have moved your hand. So that is the action which is happening, which is a purpose of actuator. So sensor plus actuator works as an transducer. You can see some examples: thermocouple, photocell, RTD, LVDT. These all you might have learned in your EMI subject. So actuators are stepper motors, servo motors, heaters, and hydraulic actuators, and many. Okay, so this is the basic difference between a sensor and an actuator. So you can see the examples to find the means to measure the light level. We can use the input devices as LDRs plus an actuator as a light or lamp. So you can see for temperature, you can have a thermocouple, thermistor, thermostat, or resistive RTDs, and the output device can be heater and fan. What do we mean by this, ma? What these are all input devices and these are all output devices, right? So, for example, most of the students, from past 15 years, what I have seen is, the moment we talk about mini projects, first they'll come with smart traffic control system, right? So in a smart traffic control system, what happens is, you come up with a thing where automatically the lights will be on and off based on the light that falls onto the light dependent resistor. So here, whenever the sun is there, means it is brightly lit, means sun is there, what happens? The photon energy will be onto the LDR. So this light dependent resistor, what it will do, whenever sun rays are there, or it is a daytime, the light dependent resistor is going to provide a minimum current to the light, such that the light will not glow. Whereas when it is dark, when it is night time, at night time, your LDR is going to offer very less resistance, and because of which high current will flow to the lights and your light will be illuminated. Means what is happening automatically? Because of the light which is being projected onto the LDR, the output device, which is the lamp, is switching on or off. So this is how a transducer is working. So transducer consists of a sensor and an actuator. Sensor is the one which is going to take input, based on which the output, whether an LED has to glow or not, will be decided. And similarly, thermistor, thermocouple for temperatures. For example, you have in your home, when you set the temperature to of an AC to 16 degrees, at first it will not be 16. It will start at 28 or 27, then slowly it comes to 16. Once it comes to 16, what happens? Your a fan mechanism, means a cooling mechanism will stop, and later when the temperature of the environment increases beyond this level, again automatically your AC compressor is going to work so that it maintains the temperature to the required 16 degrees or 18 degrees, whichever you fix. So like that, there is one input, there is one output. Okay. So now these sensors where only if it means if the slide dependent resistor, the smart traffic control system, whichever we have spoken, if this is not connected by internet, then they are general sensors or general transducers. Whereas if this transducer is combined with a processing unit and a communication interface, then it becomes a smart sensor. And these smart sensors are the one which are going to be useful in IoT data collection. Okay, smart sensors. Smart sensor is an analog or digital transducer which is combined with a processing unit and a communication interface. See, smart sensor is different than normal sensor. Smart sensor is a combination of transducer. So when I say transducer, sensor plus actuator is there. Okay, sensor plus actuator, and these two which become a transducer is combined with a processing unit and a communication interface. Why processing unit is required? If at all an action has to be performed based on this data which it receives from the transducer, a processing unit should be there, and that information should be communicated through a communication interface to the person. And if such communication interface is there, then I can call it as a smart sensor. So this smart sensors consists of a transduction element, signal conditioning, electronic and controller processor that supports some intelligence in a single package. Okay, so these may also be called as system on chip also. So smart sensor can sense, collect, display, and monitor. These are means it can be used for data conversion, bi-directional communication, take decisions, and perform logical operations. Okay, so this is what a smart sensor is. And types of smart sensor, we have hybrid type and integrated type. So smart sensor hybrid is one where the bus interface, the A to D converter, and the sensor are connected in are attached in different forms. You can see in the first onto the left, onto your left, first bus and A to D converter are connected, but through some lines, sensor is connected. So this is one method. This is the other method where the input is taken from the bus interface and it is connected to a digital one. Next, after receiving the digital input, it is again converted into analog by through the lines, and then it is given fed as the from the sensor how it is moving towards the bus lines. Okay, so in the third configuration, sensor is combined with the interface, digital to analog interface, and the output of digital to analog is given to the bus directly. Okay, so this is how hybrid sensors are. And integrated smart sensor is the one where all these things are embedded onto a small chip. Okay, so we can have magnetic devices, chemical devices, optical, mechanical, and thermal devices all together. A small chip which can be used, and this becomes an integrated smart sensor. Sir, I may require 15 more minutes. Can I?
Yeah. Go ahead, ma'am. Go ahead.
No problem.
Yeah.
Okay. So here, a smart sensor network, what it has. So you can see this is the sensing element, which is the main one, which is our smart sensor. And from there, you are going to have some signal conditioning unit. From there, an analog to digital converter or digital to analog converter, whichever it is required. And it is given to the application program like a system or a processor, which will be connected to a memory or a local interface or to the communication interface. And this in general, this is a general scenario where whether it is smart traffic lights system or home automation or checking the temperature, whatever the small mini projects you are doing using Arduino or microcontroller, the application program is there in your microprocessor or microcontroller. And at times we may require memory to be attached or inbuilt memory we are going to use. For example, 8051 microcontroller, if you see, all controllers, microcontrollers will have inbuilt limited memory, which can be used for application. So in that aspect, that 8051 or whichever microcontroller which you are going to use is going to have the application program plus memory. And if you take an Arduino, it can be connected to Arduino or 8051 microcontroller. It can be connected to some local interfaces where I may require some inputs or output ports to be connected. And using 8051, we may not connect the Wi-Fi, but using Arduino Uno, there is Arduino Uno and Arduino some series, we can connect Wi-Fi modules also, where the information can be passed. Okay, so this is how a general smart network will be. And the same, what are the things which are available in this particular network? So you can see a sensing element is the starting. There may be, and at times, whatever the sensed signal is there, that might be of low amplitude. So in such case, an amplifier may be required to enhance the strength of the signal. So it may require an amplifier, sample and hold circuit. So this sample and hold circuit, analog multiplexer, A to D converter, together you can have, and you can have some offset and temperature compensation, digital. Means these are the basic things. We are not saying that all are required. Mostly, depending on what application you are going to use, that few of these items are required, few of these elements are required in a smart sensor network. So here is an example where this is the main processor, and a serial communication is connected, A to D converter is there. These are the transducers. In place of this transducer one, for example, you have a DHT sensor. DHT is what? Humidity and temperature sensor. So transducer one is your humidity and temperature sensor. From this, the information is taken and given to the ADC, and from that, if the temperature is high, means processor will receive the data stating that the temperature is this much. So based on that, if the temperature is beyond some value, what it has to do? Using serial communication, it can show, means generally we connect LCD display to a serial communication port. So you can show on the LCD that the temperature is so much, or the same information can be sent to the outside world or to the IoT device, means API using an Wi-Fi module or something, you can send it to through to your mobile. Means a message, you can send a message to a person, whoever is connected, whoever is programmed in this processor. Means in the processor, while writing the code, we are going to assign which particular uh, ID has to get this message. So automatically, when something happens which is not uh, where alerts have to be raised, so alerts will be raised accordingly. Okay, so you can see the central processing unit, which can be a microprocessor or microcontroller, some memory, some battery, and communication module. So these are the basic things what you have. So you can see the signal processing, how it is done. I'll just skip through this. So we all know that a sensor is like a chip, right? So we know that silicon is mostly used for fabrication of chips, but silicon has got one disadvantage where reverse current ratio is very low. Means uh, what you find is it has got sensitivity issues. One problem with silicon is that its sensitivities to strain, light, and magnetic field show a large cross sensitivity to temperature. Reverse current temperature ratio is very, very low. Means where very small changes of temperature ratios can create large variations in its working. So, silicon is not preferable nowadays for the chip, and they use gallium arsenide, which has got similar properties of silicon and which has got high performance and high means it is very less sensitive to these problems whatever are faced by silicon. So for smart sensors and all, gallium arsenide is used, and just this is an fabrication method how it is done. So the advantages you can say is smart sensors takes over the conditioning and control of sensor signal, reducing the load on the central control system, allowing faster system operation. It can provide high accuracy, and nowadays smart sensor system means smart sensor may be a bit higher price compared to conventional system. But when we compare the cost with the ease of maintenance, ease of programming, ease of adding new sensors, like this, if you see the advantages over the cost, we feel that the advantages are going to weigh more. Therefore, smart sensors can be easily acquired and used, and individual controllers can monitor and control more than one process variable. When it is a smart sensor, it can monitor, as I have told you, DHT. DHT is humidity and temperature. Both physical quantities can be monitored or detected using a single sensor. Okay, so it will give us an ease. So disadvantage is, if we upgrade to smart sensors, care has to be taken when mixing old devices with the new sensors, since they may not be compatible and there may be some failures of wires or something. In case if any wiring or some problems occur, if there is a backup plan, some redundancy is being maintained whenever it is designed, then this problems can be solved. Okay, so these are very few disadvantages of the smart sensors. And And you can see the applications in industrial, automotive, fingerprint recognition, pattern recognition, telecommunication, smart toys, smart test, and biomedical applications. Most of the research in image processing or biomedical medical imaging is happening on this sensors, and people are coming up with ideas where they want to design a chip in which the moment the chip comes into contact with the person, it can identify the BP, means all, not only just BP, heart rate and all. See, your smart watch has got a sensor which can tell the heartbeat and at times BP also. But more than that, medical imaging, this sensors can do. Its chips are designed to do more than that. Okay, so MEMS and process control and defense applications, mostly it is used. And I would like to summarize my presentation, where I would like to say that the sensors and actuators are the actual heart, are the main elements from where you can reach towards your AI. So without a sensor, there is no data. And if there is no data, that data cannot be connected to net. And if there is no network of this data, no artificial intelligence is going to work. So everything starts with these sensors. So automation is possible with these smart sensors. So these smart sensors are potentially cheaper, but offer high performance and reliability. And they are much smaller in size, and they are employed in many applications using transportation, including transportation, healthcare, and sensor signals can be amplified and properly processed, can be multiplexed, and are buffered, ready to be received by microprocessor or controller, and offer a standard data stream to the user, thus making the entire sensing module behave like a system periphery rather than a passive component. So with this, I summarize. And
So excellent information ma'am has brought us. Participants, if you have any queries, you can put it in chat box or unmute yourself.
Now you can, I'll stop sharing so that I can see the chat.
Participants, if you have any queries, you can speak. No doubts, ma'am. Explanation is nice. Okay.
Thank you, Durgesh.
And Durgesh. Yeah. Anyone? I think, how can we select AI technique, Kalpana? Okay.
Like, for what, means, what do you mean? What
Kalpana,
exactly?
can you elaborate your question?
How can we select AI technique?
Yeah. Okay. Durgesh, okay, quiz will be shared. Okay. Yeah. There are different types of AI techniques. So which technique?
Depending on the application where we want to use this AI, whether it is a domestic application, we have seen, like if you have a single application, like only one thing has to be done, then you will go for weak AI. I have mentioned in the classification, no? Based on the capabilities, based on the functionalities. So if the capability requires only one function to be performed, then we will go for weak AI only, not weak AI or narrow AI. Whereas if you have a very complex thing which has to be performed, then we can go for super AI or general AI, like that. Okay. And most of the times, functionality wise, we have come up with only two categories. I have said, So what are those categories, ma? One second.
Okay. So with short notice, ma'am has brought us very good information based on some sensor technology, sensors, actuators, and how it is used in our AI/ML IoT environment.
Yes.
Ma'am also underlined some beautiful example, the how skin sensor can get the work done. That signal is being transmitted to the mind, brain, and then hand will get automatically. So that's a very good understanding for us. So I am very much thankful to Dr. Padmavati ma'am. She has taken her time and she come up here with some good understanding for us. So over to Sai. Sai.
Yes, sir. So thank you so much, ma'am. Again, I would like to extend a formal thank you on behalf of IIT Pune chapter, Buds Engineering Academy, and Civic Incubation Center. So thank you so much, ma'am, for joining us. We are really grateful for all the insights you have shared with us. Thank you,
Yeah.
ma'am.
Thank you for providing this opportunity. Actually, last 6 months before also, sir asked me to take a class, but that time it was not possible. But this time it could be made, and that too yesterday. I think you have asked me to take the class. So, but still I could take this time, and I'm very happy to take the class. And I thank all the organizers of this program. Like I came to know that this is a free program, where we can join freely. So it's a nice initiative taken by IETE Pune student chapter. So I wish you all the best and thank you for giving this opportunity.
Thank you, ma'am. Thank you so much. So now I request Arjun sir to please take over the session and complete it. Sir, we are unable to hear you. Can you please unmute?
Yeah, we'll go ahead. Yeah.
Yes, sir. Yes, sir.
Thank
Please
you once
take over.
again, ma'am. Okay.
Thank
Okay.
you, sir.
Okay. So now we'll continue the same discussion further as Kalpana. Yeah, Vijaya. Thank you. Okay. So the Kalpana, she has also brought some query, the techniques, how we have to select. So here, concerned with our today's for discussion, here we'll discuss algorithms related to AI/ML and IoT environment. So there are different algorithms for our AI/ML and IoT environment. So many algorithms are there. So one of the algorithm we have discussed earlier is a linear regression algorithm we have seen. So today we'll try to concise. We may not be able to discuss all the algorithms, but few of the algorithms, as I think we have seen earlier, the linear regression algorithm in this environment. As Dr. Padmavati ma'am has given insights of the sensors. So the data is being transmitted from the sensors over the cloud, and then the data is aggregation, and then data is being again transmitted to the destination, and remotely the sensors, even Chandrayaan is again the highest technological achievement, but the sensor is required, as ma'am has also underlined, different sensors, actuators and all. So in this, it's a technology, the artificial intelligence, machine learning, and the IoT environment. So first of all, I will try to concise some sensor. So this is our today's topic for discussion uh, right now. So this is a AI, ML, and IoT environment. The different algorithms are there, but here we'll try to see some few of the algorithm. We'll try to see what are the different algorithms or techniques we need And out of that, because of the time constraint, we may not be able to cover today all these algorithms, but one or two algorithms we'll try to learn. So you can see this is one of the algorithm which we have seen earlier. That's what the linear regression algorithm. Now linear regression algorithm, you can see the basically the fundamental machine learning algorithm, machine learning, and that falls under the category of supervised learning. So last class also, our experts already briefed you about, they discussed about the supervised machine learning and unsupervised learning, machine learning. So the in simple way, as I put it in the first day itself, the supervised, the learning, for example, with the teacher or under supervision of the teacher, we can call it as a supervised, and with the learning without that, what the unsupervised. So here, this algorithm, which we have discussed earlier, that falls under the category of supervised learning. And it's used for predicting continuous numerical outcome based on one or more input features. Based on one or more input features. As I given an example earlier, as we have seen the example, suppose different images like facial images, we are trying to segregate. Then suppose the images of the trees, forest, or image of the human, that our network is to be trained, our machine learning algorithm is trained. And then if you present that particular image, then our machine learning algorithm will detect whether this during the testing phase, actually training phase, you have to train and then testing phase, the image will be detected. That's what the features you can call, as I underlined earlier, the biomedical, our other features like that, some features. That's what the more input features. And going to the in the context of IoT, linear regression can be applied to predict trends. Just like when you browse something on Google browser, then some of the keywords, when we start typing, automatically some previous keywords will be start appearing in front of us. So that's what you can call it as a linear regression. Means the previous will be predicted. Applied to predict trends, means which kind of letter we are going to print. Then such as temperature changes or sensor readings. For example, present temperature is 10 degree, then next is 12, 13, 14 during the summer and the different season. Then how temperature will behave based on the past values, you will be able to predict the future value based on the some probability theory and stochastic process. You can find the mean value, average value, and all. So based on that, it's possible, just like a statistics values, we can predict the future values. Suppose tomorrow about the weather prediction and all that. Some of the examples we have seen earlier also. Now, such as temperature changes or sensor readings and make predictions about a future value. That's what the linear algorithm or linear regression algorithm, which we have seen earlier. And if you look at for this algorithm over here, then you can see on the x-axis and y-axis the actual values and the predicted values. So if you check the features, then actual values, you can see the dots, the blue dots, and the based on the past values of the blue dots, you can plug what the values for the future. So that's what the algorithm, linear regression algorithm. I think I have given some codes also earlier, which we have discussed earlier. Now just first of all, I will try to show some of the algorithms. We can see it here. So I hope you understand. As of now, we are trying to see different algorithms required, and in that algorithm, one of the algorithm which we have discussed earlier, that's what the linear regression algorithm. Now, second important algorithm over here is a k-means clustering algorithm. Now that k-means clustering algorithm, you can see it on the screen over here. Again, the k-means clustering it will fall under the unsupervised clustering algorithm. So as we have seen earlier, the linear that will fall under category of unsupervised learning or the algorithm. Now, this unsupervised learning means, as I underlined earlier in simple language, that what we are learning, the algorithm machine will learn the without the teacher, by himself, by observations. That's what the we can call it as a unsupervised. So this K means clustering algorithm that we'll try to again see right now. So this is a clustering algorithm that's useful for partitioning data into groups or clusters based on similarities. Similarities means, for example, different images are given, then provided to the system. Then the images based on some forest or buildings and trees, and images of humans might be male, female, boys, girls, and all. So naturally, the value, the predicted value for the humans that will fall under some bracket value. Bracket value means some cluster value whose x value and y value might be ranging, suppose 2 to 4, or suppose 2 to 4 for x and 2 to 4 for y. So that's what the bracket. So some of the feature, it may be suppose 2, 2.2, 2.3, some of might be 3, like that. But the range is some images based on the forest or buildings or trees, and that clustering value might be suppose 8 to 9 or suppose 6 to 8. So that's what the bracket of the range, and that will be categorized or clusterized. That's what we can call as a K means clustering. And in IoT applications, K means can be applied to segment devices or sensors into groups that exhibit similar behavior, helping in better understanding patterns and anomalies in the data. So I think the sensors, as Dr. Padmavati ma'am has underlined beautiful ideas about the sensors, hybrid sensors and all. So as you know, in IoT environment, the sensors are generating tremendous data. That data might be in billions and billions of bits of data is being generated. And that data in the cloud, you can call it as a data. You can some statistical analysis or production values or some processing analysis you can do on that particular data. So in IoT, K-means can be applied to segment devices, sensors into group that exhibit similar behavior, helping in better understanding pattern and anomalies of the data. Now we'll try to see this algorithm, but you see the values for suppose the human face features and the non-human face. It might be a non-human, or suppose humans or the animal features. So I think feature extraction we have already seen. So the here you can see the value. Suppose the red, you can see it here. So value, you can see the x-axis value and you can see the y-axis value. So it is in some particular bracket or in some particular cluster. So features of the human face values that will fall under suppose red cluster, and features of suppose the forest values or some buildings and trees, that features value falls under suppose the -5 to -10 or some 6. That's what the green dots are. So that's what the clustering, and for that purpose the basic algorithm used is a K, the clustering, or K means clustering algorithm. So for that purpose, again, I have given earlier the one of the thing which is I have given that again here for example, I think this is a clustering. I will see just 1 minute. So this is again error, but yeah, for right now we'll try to see the clustering algorithm if it is functioning over here. So as usual, if you are having with your laptops, then you can go with your yeah, you can open your Liplit first of all. That will try to, if possible, will try to see this K clustering algorithm over here. So Just give me 1 minute of time. First of all, we'll see the algorithm, and then we'll try to, yeah, 1 minute. Just I will, class means the data. Yeah. So here, this is what the algorithm. We'll try to see once again. So this is a algorithm. Why just we'll say run. Yeah. Yeah. Otherwise, first of all, we'll try to see here stepwise. This is a decision algorithm. Yeah. Yeah. So this is this is algorithm. I think it might be visible. So you can have your the replayed environment compiler, and the algorithm which we are trying to see. This is a K clustering algorithm, and we are having a compiler that's a Python compiler, and with that compiler we are trying to learn this particular algorithm. Now in this algorithm you can see first of all we have to import as I told you earlier the numpys, the pandas, different packages of our Python. So here you can have one of the important package for this particular algorithm. Key means algorithm. So here you have to get it first of all the numpy. This is a package required. So this is a numpy, and then you can see here this what the plotting we may get this plotting. So for that purpose we need another this package we can get it import easily, that is a matplot library and .pyplot as a plt. So these are the two packages you have to get it imported. So if you go for the replit, then automatically it will get downloaded. If you have open id the environment, then you have to get it download. Else if you go for the replit, then this package just you have to say it, then automatically it will get downloaded. If you go for some program is Python compiler, then you have to say that pip and then you can download this particular two packages. Then one more package we need, that's what the sklearn.cluster, and this is what the you can import the key mains. This package you can get it downloaded. Of course, replit it will get automatically downloaded for that. And then some data set is also required. So here you can have a sklearn, that the package that's a data sets, and you can import as a blobs or that data. So these are the packages required for our algorithm as of now. Then I think you are already aware of that whenever some face image or some the data of that image is being presented for our algorithm, then I think we have some basic knowledge of the sampling, the features, and the clusters. So here, how many clusters we are going to present, and how many features we are going to predict. For example, the human face is there, for example, then the eyes, eye biometric, or suppose nose, or so that's what the feature, the distance between the two eyes, like that. So that's what the feature. So here we are trying to see the two features, and we are our sampling we are taken as a 300. And here cluster, you can see cluster we are going to present suppose 3. So here you can see this is a red cluster, and this cross is the center of the cluster, and this is a another cluster over here, and this is another cluster over here. So here we need a 3 cluster, and then here we need a x values and y values. So you can have a make a blobs, the dot, and you can see the samples, the features, the center, the cluster, and the random state. So that's what the we have defined the x values and y values. So now moving to the after this, just like parameter declaration. If you look at here, this stepwise also. Then one minute, where it is, yeah, okay. We'll go for the stepwise analysis also. Just a minute. I will where it is. I will go it for the stepwise analysis. Yeah. Okay. We'll see it here. Just I will open my Python over here. Yeah. Okay. Okay. First of all, I hope this thing it might be clear to you what we are trying to see in this algorithm. Here we have defined as the number of the clusters and the features. And then the next step you have to go for the k-means clustering model. So this is a k-means clustering model, and for that you can define the k-means cluster model, and then you have to fit it that model fit. The function used here is a model dot fit, and then this is what the step number 1 for our algorithm. And step number 2 for our algorithm over here is the cluster assignment and cluster center. So you can see it here, what we have seen. This is a cluster center we'll get at the execution. So that cluster center, you can get it fit here. We can define as a cluster underscore center, and then model dot cluster center. So that center and cluster assignments, you can do it for the step number 2. And then that should be visualized. So suppose this is the x-axis and y-axis. Then suppose some of the feature values, k-means values here, some of the feature k-means values here, like that. So this we can call as a scattering. So for that purpose, we need a visualization of the data features which we have provided, and that visualization we can achieve with the function over here. That is a plot scatter function, and with that plot scatter function, you can achieve this particular cluster values here, this cluster values here, and so on. So for that purpose, we need a scatter. And then for our the labeling, the next step you can see for our here, the labeling is over here. So labeling, you can see the y-axis is a feature 2, and you can see the x-axis, you can see the k-means clustering. So this we have to give the we can call it as a naming also we can call. So for that purpose, you can do the labeling. So you can see the plotting x label and plotting y label and plotting the title. So plotting the x label, y label, and the title. So that's what the algorithm. And here you can see this particular algorithm. Yeah, decision tree. I will get it. Yeah, this linear regression, decision tree, and the clustering algorithm. I hope this clustering algorithm, it might be, yeah, K means clustering. And we'll see some stepwise also. Just 1 minute. I will put it here. The stepwise we'll try to see. Yeah. Yes, I will put it here at the end. I hope it might be clear. The K means clustering algorithm we are trying to see. Yeah. So in K means, yeah, here you can see K means. So first thing we have seen is a initialization. Choose the number of clusters you want to create, denoted as K, and randomly initialize K points in the data set as a initial cluster center. And these initial points are often referred to as a centroids. That's what the first step. And then the next step, you can see for each data point in the data set, calculate the distance between the point and each of the k centroids. Assign the value point to the cluster whose centroid is a cluster to it, and this step forms cluster based proximity. And that step you have to update. That is called as a recalculate the centroids for each cluster by computing the means of all data points assigned to the cluster. The new centroid will be the center of the data points in that cluster. And again, it will be repeated in the next. So the next step will be repeat the assignment step, where each data point in the assigned to the nearest cluster based on the updated centroid, and update steps where centroids are recalculated iteratively. Iterative means again and again, and until the centroids no longer change significantly or a predefined number of iterations is reached. So that particular receiving data set to be plotted or diverted to the particular the cluster area. Now moving to the next, that is called as a convergence, and this algorithm converges when the centroid stop changing or when the maximum number of iterations is reached. And at the result, you can see at the end of the iterations, you have clusters of data points. Each cluster is characterized by its centroid, and the points within a cluster are more similar to each other in terms of their features than to point in the other clusters. And choosing the value of the k, that's what the name is. A k means clustering. So you can see selecting appropriate value of k is a number of clusters, is a critical aspect of k means, and it can be determined using technique like elbow method or left-out score method, which measure how well separated the clusters are. So how the values of the clusters are getting separated, so that k value we have to choose intelligently. Now, k-means works best when clusters are well separated and have a roughly spherical shape. It's sensitive to the initial placement of centroids, and running the algorithm multiple times with different initializations is recommended. And lastly, the k-means has applications in various fields such as cluster segmentation. So one of the example, as we have seen right now here, is the image compression, the document clustering, and market segmentation. However, it's important to note that k-means may not work well with clusters of varying sizes, densities, or non-spherical shapes. In such cases, more advanced clustering algorithm like DB-scan or hierarchical clustering might be more suitable. So that's what the last class, I think we have seen the linear regression, one of the algorithm, and today we have seen the k-means clustering algorithm. So of course, many algorithms are there, as we have seen over here. So here, one of the algorithm we have seen is a linear earlier, and right now we try to learn the k-means clustering algorithm right now. So before moving to the next, just first of all, you can see here why we are trying to understand this different algorithms. You can see algorithms related to artificial intelligence, machine learning, and IoT have broad range of applications. One by one, we'll try to see that often intersect and complement each other. Here are some of the basic applications that algorithm. So AI, ML, and IoT. So these applications where these algorithms are basically used heavily. So these algorithms are, which we are trying to learn right now, these algorithms are heavily useful or used for predictive maintenance. Now, in AI ML, algorithms are used to predict when IoT devices, machinery, or equipment are likely to fail or require maintenance, and this helps reduce downtime and improve operational efficiency. Means, for example, nowadays some industries, robots are working. Robots are heavily used. For example, mechanical industry, more than whatever what robots, as I have seen somewhere that available in the world, more than 60% of the robots are employed with mechanical industry, especially. So the machine, so the life, we may say that robots will work for 24/7. So that's what the machine. But when that machine is will be going to down, or it may malfunction, or it may not work, so that can be predicted with this particular algorithms over here. So I hope you understand this AI/ML algorithms, what we are trying to learn right now. These algorithms are very useful, so we can predict the operation or machine's performance well in advance in the future. Means after 10 days or after 1 year, the what could be the downtime, or when could be the machine under maintenance. That value we can predict in advance. That's what the one of the main objective of this particular different algorithms which we are trying to learn right now. Now moving to the second one, the smart agriculture. I think you are already aware of what the agriculture and what the smart agriculture. So AI-driven algorithms analyze data from IoT sensors in agriculture to optimize irrigation, monitor crop health, predict yields, and make informed decisions for better crop management. I think you might be aware of that. The some particular crop is there, so IoT sensors are installed entire the geographical locations of that particular we can call it as a farm, and that IoT sensors are collecting the data. So based on that data, easily we will be able to predict the next after 10 days or after 20 days or after 10 days or 5 days. So what could be the irrigation decisions, means where when next irrigation cycle is to be planned. That kind of decisions, this AI enabled algorithms will help us to predict the to take the decisions, or might be some government bodies or some decision making bodies will for the crop management or the farmers. Now these algorithms which we are trying to see right now, as we have seen, one of the linear regression algorithm, and second we have seen the k-means clustering algorithm. Now like that, some 7-8 algorithms will try to just enlist, because of the time limit we may not be able to, but you can see the one of the application in healthcare, also healthcare monitoring. So you see the these algorithms are used. You can see IoT devices collect patient data, which AI algorithms can analyze for early detection of medical conditions, remote patient monitoring, personalized treatment recommendations. I think you can understand what the personalized and what the remote patient. So IoT sensors are collecting the data, and based on the AI algorithm, so doctors will be able to take a decision about the patient's health well in advance, so that lives can be saved. So that's what the algorithm we are using in the healthcare segment. Now, going to the energy management. In energy management, you can see IoT sensors gather energy consumption data that algorithms can analyze to optimize energy uses, efficiencies, and reduce the cost. For example, we are using the energy, and the energy of whole requirement of our country, some particular country or the state. So the IoT sensors will start collecting the data, and the wastage of energy or demand of energy or wastage of energy or quality, in terms of quality of the energy, that data can be analyzed. Whatever data collected from the IoT sensors, that can be analyzed, and decision making authorities will be able to predict the smart decisions well in advance. And for that purpose, these algorithms will help them in the energy sector. Similarly, these algorithms will also help in the autonomous vehicles. I think driverless car is one of the example we have seen earlier. And in this algorithm, you can see, for example, driverless car. So where you can take the real-time decisions. So that real-time decisions can be taken. Real-time decisions can be taken here with the help of AI algorithms. Similarly, moving to the supply chain side, I think most of the you see whatever job is getting created, so job creation. So in the world, generally, if you look for the 100 jobs are getting created, out of 100, as per the little old data available with us, the around 57 jobs will get created in the supply chain sector. So supply chain sector is one of the biggest job creation happening in the supply chain sector. And in that supply chain sector, this AI enabled algorithms, which we are trying to see right now, these algorithms will help to take logistic decisions. Means in which area, which kind of product will get demand, or some particular company, or suppose some internet users or data users, so in particular country or the region or the area. So in future, what could be the present demand and what could be the future demand in terms of supply chain, that will be easily predicted with the help of the AI enabled algorithms. That's what the algorithms we are trying to see. Similarly, these algorithms are used in the environmental monitoring. I think environmental conditions, it's again, environment is a big issue. I think e-energy, e-green, that we are talking about it. Then Yeah. So here IoT sensors collect environmental data that's about the air quality, pollution levels, weather conditions, which AI algorithms can analyze to monitor environmental changes and product patterns. Similarly, uh, there is a these algorithms will be used for the smart cities. Now in smart cities, you can see, I think you can understand about the smart cities. So AI and IoT are heavily used to create efficient urban infrastructure, monitor traffic patterns and manage waste, optimize public transportation and enhance public safety. That's what the algorithm are useful to take a decision in the smart cities also. Now moving to the industrial automation. Again, these algorithms will be useful for industrial automation. So AI algorithms process IoT sensor data in manufacturing environments to optimize production, detect anomalies, and ensure product quality, where this industrial automation and this particular algorithm is again useful. Now moving to the retail industry. So here also again, suppose some financial companies like LIC kind of people, some companies like Big Bazaar and all these people, they will try to communicate with the continuously people, and they will make a call in terms of the in terms of text or email or the sound. So especially from the speech or the conversion happening with the people, and that data heavily they will store the data, and that they will do the data analysis, and based on the features predicted from the speech recorded with these people, they will suggest the desired policy for that particular customer, or they will try to understand the customer behavior well in advance. That's what the customer behavior. So these algorithms are heavily used to in retail analytics to understand the customer behavior. Similarly, the personalized shopping experiences and optimize store layouts. This again algorithm is used. Similarly, building management. So IoT sensors in building collected data, means occupancy, temperature, lighting, which AI algorithms can use to optimize energy consumption and improve the comfort. So this is again one of the area where these algorithms are heavily used. And the one more area is wearable devices, where these AI algorithms are used. Uh, Again, the smart homes. In smart homes, I think smart homes, you can see it here, the uh, smart thermostat, means depending upon the our requirement in our house, the AC temperature can be automatically maintained, or the lighting can be maintained, or the music system, the sound system of the home. That's what the different systems that can be managed or predicted the behavior. That's what the algorithms used. Similarly, these algorithms are also used in the fraud detection. Now, this IoT generated data combined with AI algorithm can detect anomaly or fraud or financial transaction or wrong transaction, or helping real-time fraud prevention. So frauds can be prevented with the help of this particular algorithm. Similarly, moving to the energy response, AI-driven algorithms can process data from IoT sensors during emergencies to provide real-time information and coordinate responses. Also, these applications highlight how the between AI, ML, and IoT leads to innovate solutions across sectors and improving efficiency, improving decision-making capability, and improving the comfort or the quality of the life. So for that purpose, you can heavily use the AI, ML, and IoT. Now, in this AI and ML and IoT, so one of the algorithm we have seen is a linear regression, and later the algorithm we have seen the K-means clustering algorithm. Now, moving to the one more algorithm here, just quickly as time is running, but we'll try to see one more algorithm over here, and then just we'll define the algorithm so that you can try later, because it won't be possible feasible for us to cover all the algorithm. But just I'm trying to give the trends for you. So there is a one more algorithm, that is a decision tree based algorithm. So to utilize all these things, the next algorithm, the decision tree algorithm. Now, in this decision tree algorithm, you can see it here, the decision tree algorithm. Decision trees are versatile algorithm that can be used for both the classification. Okay, it is used for the classification uh, and regression. Yeah, yeah. So you can see it here now. Yeah, yeah. Classification and regression task. They work by recursively partitioning the data into subsets based on the values of the input feature. In IoT scenarios, decision trees can aid in making decisions about device behavior or predicting events based on the sensors data. So what we have seen, the different sensor data as of now, yeah. So just we have seen many applications, actually trillions of many applications are there. But we have seen some of the applications, how these algorithms will help the humans or for us, for decision making authorities to predict the decision in advance. So I think you might be aware of that, what the decisions, uh, this if you take the decision in advance, then what could be the benefit we will get. Now, this is again the decision tree algorithm. You can see here is a decision tree algorithm. So that we will try to see again, decision tree algorithm. Just if I get, this is a decision tree algorithm. So just as time is again not permitting for us, but yeah, we'll see. Uh, yeah. So here, yeah. So yes, I will try to run. Then we'll stop over here. Uh, yeah. So this is one of the algorithm used for the decision tree. So this algorithms again will continue for the next as time is running over here. Yeah. I hope you understand what the algorithms. Here are some, just I will concise this algorithm and then we'll stop. So as we have seen, one is a linear regression algorithm, K means clustering algorithm, decision tree algorithm, and as we have seen, we will be able to predict the behavior for the decision tree algorithm. There are some many algorithms, but we'll try to restrict this algorithm as of now. So yeah. Yeah. So these are the yeah. This is a different yeah. Just we'll see. Yeah. Decision tree algorithm. Yeah, decision tree algorithm have wide range of application across various domains due to their simplicity, interpretability, and effectiveness. Some notable applications of decision tree algorithms are classification problems, regression problems, medical diagnosis, customer relationship management, fraud detection, the image object recognition, quality control and manufacturing, environmental science, the education, the market research, the productive maintenance, and the personalized medicine. So these are the applications we can see. With this, try to see our today's yeah. We'll see some what participants are saying. Yeah. So this is a PDF send off. Pratik, kindly send all our mix, sir. It's IT, iOS is big. All our mixers. Previous ma'am, kind send me email. Pratik, Pratik, recordings are there. So in the recording, ma'am has displayed a email. You can see the recordings. Yes. And yeah. Uh, I hope you, Pratik, you should see the recordings where ma'am's email is there. Yes, Pratik? Pratik Agnihotri. No, you take recordings. This the here is there. This we have given, no? It's a live voice stream will be there. So there you can see the record, the shots over there. Okay, so ma'am, at the end you have explained. Ma'am has explained. Yeah. So first you see the recordings where ma'am has given, where you will find that. So you go to that when ma'am has ended. So if you are there, you will get it. Otherwise, you will get the mail there. Ma'am's mail. Is it clear? This last page. No. You find it from recordings. You will get it. I couldn't get you. Krishna, can you unmute? Is it possible for unmute? Krishna? Yeah, Pratik, you can speak here. What do you want?
Yes, sir. One
Yeah.
second, sir. I will just unmute.
Yeah, unmute Pratik and speak what you want. I have given a link. You can see the recordings. You will get their ma'am's mail ID. Anything else? Yes? Okay. All these PDFs are there. You send the PDF. Which last page I could not understand. Which PDF? No. You see the recordings. Whatever you want to share, you can see the recordings. There you will find it. So you can search it.
You can pause the recording and you can take a
Yeah, you
screenshot
can
of
pause
it.
it. You will get it. Yeah. Anything else? Okay, then.
Yes, sir. Should we end the session now, sir?
Yeah, we'll stop it here for today. Yeah. Good.
So thank you so much, all the participants and today's speaker for sharing their time and all the participants for joining. We will meet on Monday at 6 p.m. and our regular sessions will start from Monday. And the quiz link will be sent till tomorrow morning
All
for
quizzes
everybody.
will be sent. So yeah, the quiz will be compulsory. Yeah. Okay.
Yes. Okay. So, sir, with this note, should I end the session?
Yeah.
Okay. Thank you, sir. Thank you so much, everyone.
Yeah.